Got a sphere of mass 0.2 gram projected vertically downwards. So sphere 0.2 kilograms projected vertically downwards, speed 5 meters per second, from a height of 1.6 meters. Hits ground and then bounces back up again. That'll be H. Coefficients of restitution E, and E I always write down separation speed over approach speed, and it's 0.7. So I've got to find, it tells me this, I've got to find separation speed and approach speed. Well, obviously I'm going to find the approach speed first. It's going to be projected down there. I'm going to do constant equations, constant acceleration. So Stuva, and this is for Stuva for the initial. That's 1.6, that's where it starts. T, really don't care about. Initial velocity is 5, final velocity is what I want to find. Acceleration, it is going in that direction, so that'd be 9.8. The one without T, v squared equals u squared plus 2as. So v squared equals 25 plus 19.6 times by 1.6. And that gives me that v squared equals 56.36. So v equals 7.507329. Obviously keep it in a calculator. So that's worked out the approach speed, and now I have to work out the separation speed. So for doing this, I'm going to work out when it bounces up. So again, it's going to be Stuva. I could lay my work out better, but I'm trying to get it all on there. I want to find the distance. No, don't care about T. Initial velocity, I don't know what that is yet, so I need to work out what that is. Final velocity will be 0, and it's going to be going up, so that'll be minus 9.8. So I've got one more thing I've got to find out. I've got to find the initial velocity. And I've worked out what the approach speed is. So from this formula up here, I can then work out the separation speed. So separation speed will equal 0.7 times by 7.507329, and so that separation speed will be 5.25513. Obviously keep more accuracy. So that would be 5.25513. Now I can do it. I've got v squared equals u squared plus 2as. Don't care about t. And so I've got v squared is 0 squared equals 5.25513 squared. A is negative here, minus 19.6 times by s. And so I get s equals exactly 1.409 meters. So I found h. And now part 2, up here, I've got to find the impulse, the magnitude and direction of the impulse. So impulse equals change in momentum. And the impulse is going to be vertically upwards, because it's asking me for the impulse exerted on the sphere by the ground. Well, the ball's going to end up going up, so it's going to be vertically upwards. That's one mark, and we can take up to be positive, and direction matters. So up is positive, so the impulse is change in momentum, so it's going to be final momentum minus the initial momentum. Don't forget direction matters. So equals final momentum is the mass times velocity, so 0.2 times by the velocity as it goes up, and that will be, we just worked out the 5.25513 minus the initial momentum is going to be 0.2 times by the velocity, and the velocity is coming down, so that will be minus 7.5, so times negative 7.5 07, etc. And so I will end up as I will equal 2.5524918 Newton seconds. Final part, loss of energy. Well, I want to have the initial energy. Initial energy is kinetic energy plus mgh, which is a half mv squared, so it's a half times the mass 0.2 times the initial velocity is 5, so it's squared, half mv squared, plus 0.2 times by 9.8 times by the height 1.6, and that equals 5.636. I've got to work out the final energy. Well, it's not going to be moving at the end, so it's just going to be mgh. So it's going to be mgh, which is 0.2 times by g, 9.8, times by the height, 1.409. So final energy, 2.7636. And so therefore the energy loss equals 5.636 minus 2.7636, which equals 2.8724 joules, or 2.87 joules, to 3 significant figures. Most important thing, you can write it in red, direction matters whenever we're dealing with momentum, and that is the key bit here. And that's 5 done.